Hey guys, welcome back to the channel. So let's go on to the next problem. Let's see before what is this ancestor, what kind of problems will these give. So let's see. Lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition of LC and Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in the T that has both P and Q as a descendants, where we allow a node to be a descendant of X. I just didn't understand. According to the definition of LC and Wikipedia, the lowest common ancestor is defined between two nodes P and Q two nodes P and Q as the lowest node in T that has both P and Q as descendants. I didn't understand, guys, so let's see from the example. Well, this is the tree. The LC of nodes 5 and 1 is 3. The LC of node 5 and 4 is, if a node can be a descendant of itself according to the LC definition. I just didn't understand. Let's see this from the Wikipedia. Area of encounter for the common ancestor of a set of species in evolution tree, the most recent common ancestor. The lowest common ancestor, also called least common ancestor of two nodes E and W in a tree, or directed acyclic graph T, is the lowest. Tree or graph is the lowest node that has both V and W as descendants. Where we define each node to be a descendant of itself. So if we have a in a tree data structure where each node points to its parents, okay, the lowest common ancestor can be easily determined by finding the first intersection of the paths. From V and W to the root. In general, the computation time is just couldn't understand what's the lowest. Wait a minute, let's ask GPT to parse it. What the lowest common ancestor. The lowest common ancestor of two nodes P and Q in a binary tree is the lowest or the deepest node that has both P and Q in its subtree. Both P and Q in its subtree. Lowest means It's the furthest from the root while still being a common ancestor. Think of it like this: if you trace the path from the root P and P and from root Q, root P and from the root Q, the last common node you encounter in both paths is the, for example, LC of 5, 1. Both are directly under 3. Okay. LC of 5, 4. Because 5 is an ancestor of 4. Lowest node that connects both L 7 and Q. 7 and 8. 3. Formal definition: the lowest common ancestor is the lowest node that has both P and Q as descendants. Okay. So 5, from 5 and 4, if I have to choose 7 and 8, then 3 is a common ancestor between 7 and 8 because both are of the different subtrees. But for 5 and 4, 5 is the common parent. So between 6 and 2 it is 5, 0 and 8 it is 1. So, 0 and 8 it's 1. Let's write registers 3, 1. Well, this seems like not a tough problem, but here P and Q are already given, so 5 and 1. Okay. Let's see the constants. The number of nodes in the tree will be between 2 and 10 to the power of 5, and the node values will be between minus 10 to the power of 9 and 10 to the power of 9. Node values are unique. Well, this is what I'm searching for. P and Q are not same. P will exist in the tree. So let's go. Since they are unique, there won't be any duplicates. So we have to trace back as soon as we find P and Q. So let's do DFS. We'll have to traverse right and left, but if we have to find P and Q first, and we have to trace them back. What if we do backtracking? Well, now that I see this clearly, I understand the challenge here. So let's think about an intuition. So let's try going down, and while we go up, let's see if there exists a value. We go to depth, to the lowest depth, we find Q here, we keep on climbing and we find 5 here, and the common ancestor between 5 and 4 are initially 3 will be the common ancestor because it is the root of Tron. We go to the 5 and then 1. We found the 5. 3 is still the common ancestor. We go down. 3 is still the common ancestor. 0 and 8. We go down to the 4. 2 is the ancestor of 4. 5 is the ancestor of this seems to be tough. Well, let's go. Let's pass the ancestor. Let's first traverse. Now this is the parent. What parent? Let's see. It's 7. So 4 has 2 as a parent. 2 and 6 has 5 as a parent. And 3 is a parent for 5. So 0 and 8 has 1 as a parent, and 1 has 3 as a parent. Now P and Q are 5 and 1. I find 1 and the parent is 3. And I find 5 whose parent is 3 again. 3 is the common parent. And here 6 parent is 5. We have P and Q as 5 and 4. 5 has 3 as a parent, and self can also be a parent to itself, and 4 has 2 as a parent. 2 has 1 as a parent. 2 has a 5 as a parent. I guess you have to use a hash map to store the parents. If I have to check it between 1 and 2. Okay. If I have to do 7 and 8, 7 has 2 as a parent, 2 has 5, and 5 has 3. Uh, if I keep a hash map or dictionary, I mean, if we keep a dictionary, it will be so 7 key will be 2, 8 key will be 1. And 2 has 5. I just got an idea. So instead of, let's make one thing. Let's make a dictionary. Parent child dictionary. PC of node dot value equals to parent PC now we have to see 5 has 3 as a parent and 1 has 3 as a parent, so the common parent is 3. Between 5 and 4, 5 has 3 as a parent, 4 has 2 and 2 has 5. So 5 itself is a parent here, ancestor. So we go for 2. See the seems like we don't need any dictionary. 813. Well, let's start where we have left. Hmm, Go down the path and check for the value. Most common ancestor 56. 5. By the time I reach 4 or let's do one thing. Let's ask GPT for the answer. One, 3, 4, 36. My resolution is to the values in the predict for each child. The value will be the parent in the we have both P and Q letters. Which or is of the what the set the intersection of the answer correctly. Let's refine your intuition step by step so that you can reach the solution yourself. Great. What's your real goal? You don't need all ancestors or paths for everyone. Just for P and Q, so you need a way to know the path for each node. Know each node's parent so you can climb up easily. Your idea of storing fits perfectly with the second one. How could you build child while doing DFS survey every time you visited nodes? This way, once the traversal finishes, you can have each node's direct parent reference. Can you think about what traversal type is? The parent map, let's say we have both P and Q. You can now move upward from until you hit one that's already marked. Why do we only need to track T's ancestors, not both? Storing each node's full path as a set is valid, but memory admits conceptually simple but not efficient. The parent map approach gives you the same power with much less space. How efficiently stop early um, EFS. Yes, you can design and you can absolutely just with him. What do we link it up together? It has seen PRQ. Imagine this recursive function. What should it return so that the parent call knows if P or Q is in its subtree? Maybe Boolean or the node. Think about the structure. When you are at any node, you explore its left and right. If both sides return true, meaning one found P and the other found Q, then this node must be. So the recursion itself can naturally bubble up the answer. What exactly each call should return? We don't know whether The secretary has P, Q or both. If I have root, so we go left. P is found already. We go further until we find the Q. If we have it in a right subtree, maybe I can do divide and uh, uh, like the first. It's not easy. Yes, that's like so, if I found both that and if found both then Q, then I shall turn the node value where it the value so at each node your cursor exploring left. Each call tells you one of these. It found one of the targets P or Q, or it found both. Now back at the terminal. If left and right both return not null, this node is the lowest common ancestor. If only one of them is not null, that means one target was found below. So you just return the one upward, keep bubbling it up. If the current node is and the node itself. If only one of them is not null. If current node is P, if node dot value equals to P, oh, wait a minute. If left right, return if both left and right are found, and if only left is found, if right and right. If both the left and right are not found, let's see how this will go. left. Left will be none for sure. Mm, well, I guess this time it will work fine. Line number internal node. That's great. It is working fine. So shall we try submitting it? Yes, we should. Let's submit it. Before submitting, let's ask GPT, can this be even more optimized? Wait a minute. Let's submit it first. Well, this is working fine, but seems like it is not optimal. Uh, shall we see the answers from here or ask the GPT? Seeing answer from here seems most elegant. So if not root or root equal to p or root equal to return root, if not none. So if okay, well, mm, let's ask GPT. Let's try to understand from here too. That is the problem. Absolute dividend conquer. Correct to handle base case and return field. Let merge. Elegant user recursion, non-necessary small improvements. Avoid creating set repeatedly inside recursion. Okay. Node equals to p. Uh, let's try submitting it again. So small. And just trust the other. I don't know how the space complexity is order of h. So tree height. Each node visited once. Okay. So let's start discussing the intuition. The intuition is simple. This is the base case, so I guess I don't need to explain this. We implemented a simple DFS recursion where the base case returns none if it reaches the end, and there is another base case if we found P or Q nodes in the tree, then we don't need to go any, I mean, then we are returning that node if both left and right becomes. So basically if both left and right are visited, then we'll return node, or else we'll return left or right. One of them might be none. So the value that's already assigned will be returned. But I just got a confusion here. If we return in the instant when we find the node, we are not going any further. Hmm, I just did the thing. If I return node as soon as I find PRQ, what if the order the target lies somewhere deeper below that same node subtree? If I skip it and prevent left and right both from being true. But here's the key insight, the crucial point. When you return after finding P or Q, you're not stopping the entire recursion. You're just telling the parent call. After finding P or Q, you're not stopping the entire recursion, okay? Telling the parent call, hey, I found one of the targets somewhere in the subtree. Now, if the node itself is P and the other target Q lies below it, then the same recursive branch will return P and all its parents call will keep bubbling up the same node until the recursion. So no information, you are not prematurely stopping exploration. Let's find LC of 5 and 4. Guesses of 3 calls 5 and 1. 5 sees node equal to P, so it returns 5. It doesn't need to explore deeper. DFS of 5 represents the entire subtree. Okay, returns none. Okay, got it. So if it is somewhere then one of P or Q is the ancestor. Since mm, let me explain the intuition again. So if we find there is two possibilities. One, P and Q lies in left and right subtrees, or one of P and Q are like one of P or Q will become the ancestor, and the second one is both P or Q won't become an ancestor, some other will become an ancestor. If in the case if we have P or Q as ancestors, then the answer will be returned from this condition where we are returning left or right. So we don't need to go any further, we will return left or right. One of left or right will be P or Q. So in such case it will return P or Q, or else if both left and right are found, then both of them are in two right and left subtrees. We are returning the node that joins both of them. So I hope you guys understood the intuition. If you like the video, upvote it and share it with your friends and community. And don't forget to subscribe the channel, and if you have any doubts, don't hesitate to reach out to me in the comment section. I will try to answer each and every one of you. And thank you for choosing the channel again. We'll meet you again with another video. Until then, keep learning and keep pushing hard, guys. Goodbye.